a solution here.
I have no idea what we're doing.
So here's what we got. We've got this parabola. Engineers kind of doing this thing. We've got this first point over on this end. We know this top point, which is the, what do we call that thing again? The vertex. And the question is, what's on the other end?
Isn't it just symmetrical?
What's symmetrical? What are you talking about?
Well, like the vertex is like this, the symmetry, axis, symmetry, blah, 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 blah.
Hold on. Hold on, slow down. Try that again.
Well, the 6.4 is the axis of symmetry, right?
At 6.4, we have an axis of symmetry.
Yeah.
Why is...
So then you just subtract 6.4 from that one, and then you can just add that one and move it over to that one, and then you can get the answer for that one for x.
Okay, for some of us that can't... That's great. I see where you're going with that. You want to try?
No.
You already got it? Okay. David, I saw your...
I lost my
upside. No? After him? Where'd the...
I know what I'm doing.
Did he say everything that needed to be
I'll
said?
explain it better, I promise.
Try one more time. Go ahead.
Okay, so you got the y right there, like the y, the tall one. So like if you
Hold on, the y?
subtract, yeah. So if you subtract 6.4,
Subtract 6.4.
yeah. So you can move the decimal to the middle. You know the long y one, the y-axis. Is that what it's called?
So 0, 12.96?
Yeah, 0. Yeah, you want to move to 0, and then you just add 8 to it. And then that's
Wait a
what
minute.
you get.
Wait. Slow down. I want to move the 0.
No.
Yeah,
Like,
here.
so like you get this decimal to here, so you gotta like take that out, and then you just add it to this one because then that's how far it is over here, and then you get it to right here,
So let me repeat.
and then that's would be 0.
Let me repeat this.
I don't know how to explain it.
Well, let me repeat, and then you tell me whether what I'm gonna say is what you're saying. Okay? And I'm gonna try this in some simpler words. Hopefully. So you just pointed out that we're gonna have an axis of symmetry, correct? That's important because we know that whatever distances are on the left are gonna be the same distances on the
Right.
okay? So what I heard you say is you're trying to find, you know that this distance is 6.4, correct? From there to 0? I also need this distance there, don't I?
And distance is always positive.
Distance is always positive. Okay, so that means that if this from here to there is 8 units,
And then
from here to there is 6.4 units.
You add them together and you get the other one, and then the other one would be 0, so it would be like 12.4.
So
like 14.4.
So are you saying that I need to figure out this distance?
Yeah.
Okay. So what would this distance be? If this
It'd
is
be
6.4,
14.4.
and this is 8, we have. So this distance is 14.4 from here to
And that
here.
would be on the x.
So how do I get the x over there then? Add it to 6.4, right? Because that means we're going 14.4 that way and 14.4 that way. Good. So what would the x value here be? 20.8. What about my y value?
0.
Good. All right. Nice.
I was in here
Don't look
yesterday
like
and
you
I
need to go see the
stared
nurse.
at I was
I have a
doing.
question.
Go ahead.
Yes, ma'am.
So, that axis of symmetry, does that mean that if I was able to fold that parabola on the axis of
It
symmetry,
would be equal.
I could find out where the point was? If I could basically
ma'am.
take,
It's like a sheet of paper. If you fold it in half, the axis of symmetry will be where that fold is on the paper.
so if I could fold this, right,
Yes,
then
ma'am.
I could get over it. So that's what that means, right?
Yes, ma'am.
Thanks.
Axis of symmetry is like the middle of whatever you're.
I hope you never have to explain that to a group of people.
I hope I never do either.
Ever. I hope you're not running a company building
Hey,
tunnels.
but as long as I know what I'm doing, then it's okay.
Okay. Show me fist of 5. You got this. You don't got this.
Okay.
5 means you can teach it to somebody. I see some 4s out there. 3. Okay. Okay, so y'all have 3. So here's what we're saying. And actually, I'm going to go ahead and use our visitor's words. This axis of symmetry. What's your name again? I'm sorry.
Miss Joanne.
Miss Joanne. So here's what we know, because I saw a bunch of those 3s. I want to get you guys some 4s. Okay. Remember how parabolas are symmetrical?
Sure.
So let's say that if my head, my body, is the axis of symmetry, I have a point that's 5 units on this side, then in this direction, 5 units, I should have another point, correct? And that kind of repeats itself all the way through. So what we did, or what he did, was to figure out this distance here. And we found that this distance was 14.4. That means that from this point to that direction, another 14.4, I should have the other coordinate.
Like if you think about it, the axis of symmetry can also be like the 0, 0, like that line. You know what I mean? That way, like it's easier for people to see it. Like that's what
But will it always be there? And that
Oh no, I'm not saying it is. Like right now, it's not. But like I'm saying, you can just add the 6.4 to it. Is what I'm saying. Like if you think about it as it's like originally 0, 0, it could be easier to visualize it since right now it's like not on it. So like it's confusing. It's like more confusing to see the axis of symmetry.
Because
But
you're gonna
since
translate it over
yeah.
in your head.
Yeah.
Like if you just like pretend like it's 0, 0 for now, and then like once you find out the distance on both sides, then you can just add the 6.4 on it because you know that's how far it is.
Go ahead.
Are we adding 6.4 to the 14.4
Yes, ma'am.
because that we're starting at 6.4 as our like 0 and it's adding on, and so
Correct.
that's why it's 20.8.
High five.
Here, take my marker. Take my marker. So the distance from here to 0 is 6.4, and then we have another 8 to go for a total distance of 14.4. So I should have another point on that same end that's also 14.4 away. So once I take this 6.4 and I add the other 14.4, we get that 20.8.
Now I know
which
what
is
it
way
feels
out
like
that
to be a
side.
teacher. You know, it's fun.
Isn't it though?
Exactly right.
Is it though? Okay, good. So, still some of those threes that we can come back and we can touch base on that. Now, it's important. We've already been doing some of these things, right? We did the axis of symmetry. We found the vertex. We found the y-intercept. Y-intercept is always at 0, c. Our focus today is that we're going to find the zeros of the quadratic. Now, when I say zeros, we mean these x-intercepts. So we have a couple words here, and I don't think I put that one up there. So I'm going to come over in the language. I need you to know what a parabola is. Today we're going to talk about this thing called the zero product property. You need to know what a zero is and associate that with an x-intercept. And I'm going to tell you that there's so many different things that these things are called, but they all mean the same thing. But for now, these are going to probably be the two that I use the most.
Okay, that's confusing.
What's confusing?
The associate is 0 with x-intercept.
Just another word for
Those
it.
are big words. I don't know. As you
Associate-
can tell, I don't use big
They,
words.
all I'm saying is they mean the same thing. Okay, so we're looking for zeros, and these are going to be zeros for the x, because technically we also have a 0 and it's a y-intercept, but we don't really call it that. We'll just call it a y-intercept, okay? So let's do this real quick. So here's our objective. We're looking for the zeros of a quadratic equation. This is the way the book presents to you the objective. We're going to find zeros of a quadratic function, and it's in the standard form, right? Y equals ax squared plus bx plus c. But we want to see how that relates to this thing here. And all they've done is taken y and set it equal to 0.
Wouldn't that be on the x-axis then?
Say that one more time.
Wouldn't the line be on the x-axis if y was equal to 0?
If y was equal to 0, what would we get? We would get something
Yeah, on the x-axis.
on the x-axis.
Yeah.
What's on the x-axis?
The point.
The points, and that's what we're after. That's our objective today.
Oh,
Okay. Cool, so I'll let you guys write that down.
Can I go to the nurse now, Miss? You know?
You feel like you need to go?
Oh no, I'm kind of sick. That's why I wasn't here yesterday.
Take my ruler pass.
I'll be right back.
Okay. Okay, so I have a question for you. Go back. Sorry.
Thank you.
Okay, we're good. They should. They should. You guys are being way too quiet. All right.
I'm tired.
Okay.
I need a nap.
Okay.
No,
I don't buy
I
that.
can't wait to go to
I
yoga
wake up
right
every
now.
single day at 5:30. I need a nap.
I fell asleep at 12.
You guys are
Oh, I
making this.
didn't bring a shirt.
You guys are making this a little awkward for me now. Okay, can I continue?
Hello, who's yours?
Anybody still writing? good? Okay. So here's my question to you. I'm going to multiply two numbers here. Let me put this back. I'm going to multiply 2 by something, and I'm going to get 0. Can you tell me, without blurting it out, what number that's supposed to be? I can't hear you. One more time. 0, because we know that 2 times 0 will give me 0. Okay. What if I took two numbers, we'll call them x and y. Stop and think about this for a second. Please don't blurt it out. What can you tell me about x and or y? What can you tell me about x and or y? We're looking at this right here. Hold on. Leo, what can you tell me about either one of those? What's going on here? I'm multiplying x and y, and I got 0.
I need a little help.
Okay, so let's think about this. We're taking two numbers and we're multiplying them. And when we multiply them, we got a 0 for an answer. What does that mean about x or y? Remember what happened up here?
Equals 0.
What equals 0?
X and y.
X and y? Could it be x and y? It could be x and y. Upson?
It could also be one or the other.
It could be one or the other, but it could also be both of those, okay? Questions on this idea. If I take two numbers and I'm going to multiply them and I get a product of 0, that means either x was 0, y was 0, or both of them are 0, okay? Guess what that's called?
Zero product property.
That's called zero product property, okay? So, here's the way they write it as a rule for you. If I have two values, it's already as big as I can make it, A and B, and I multiply them, I get 0, then that means that A or B are 0, or it could be that both of them are 0.
Wait, so what's the purpose of this? Like, I don't understand the purpose of it.
What are we trying to do?
Zero product?
We're trying to find the zeros. Do you remember what I called the zeros? I barely reached that. Remember these points? That's what we're after. Okay? Anybody still writing this rule? Okay, cool. So let's do that. So we have parabolas. Let's go ahead and do this, and I want to write this as y equals for now. I want to write this as y equals, because we already know a couple things based off this, Daisha. We need to be able, we should already know if the thing's going to be facing up or if it's going to be facing down. And in this case, it's going to be facing
Down. Oh, wait.
show me up, show me down. Oh, some of you guys aren't voting. Show me up, show me down. Okay. What determines which one of these things in here is going to tell me whether it faces up or it faces down? See, Lali? Negative 5x.
X squared.
Thank you. Huerta?
X squared.
X squared. More specifically,
Wait, is it six?
I thought it was before X.
X squared.
Is it the
Okay.
A?
let me go back one slide. Okay. So as a reminder from yesterday, the value of A, where is A located on this? It's right in front of the x squared, right? If that is a positive, then my parabola will be positive, it'll be smiling. But if that's a negative, then what's my parabola doing? It's gonna be sad, it's gonna be frown, it's gonna be sad. So, if I have a positive parabola, my A value is gonna be positive. I'm gonna lead with a positive. If it leads with a negative, then my parabola is gonna be facing down. Okay? A is positive, up. If it's negative, then it's gonna be down. Let's go back to here. Is my parabola facing up, or is it facing down? It's gonna be facing up. So,
What's the value of A?
One.
okay, so positive is gonna be facing up. Next question. We want to figure out where the vertex is gonna be at. Before I can find the vertex, what do I need to find? Yeah, so I want to find out the axis of symmetry.
The Y.
It's gonna be C, right?
Not C yet.
B.
What goes right down the middle of my parabola? There's a name for that thing, that line. The axis of symmetry. How do I find the axis of symmetry? How do I find the axis of symmetry?
Is it 2A or divided?
Is it? I asked the question. What do you think it is?
Is it 2A over 2B?
No, it's B.
Negative B.
Yeah, negative B.
Okay, so we have a formula. I'm going after this axis of symmetry. Stop and think about this. Think about yesterday. Why do I want to find axis of symmetry? What makes that important? It's easier. What's easier? Why? Why is it easier to find the vertex?
Because you already got the S value.
That's for what?
That's where you can find the S value of the vertex.
On the axis of symmetry?
Yes.
Yes.
You can find the S value of the vertex on the axis.
Good. So let's do that. So let's come over here real quick. Someone identify A, then B, then we're going to identify C. Look at those. Identify those real quick.
What I miss?
Mia, what's A? What's the value of A? 1? Where'd you get that? In front of x squared lives a 1. Next one, B. Question goes to. Oh, I thought it would be Luis. What's my B value? Negative 5. And then Daisha? What's my C value? Positive 6. Good job. Okay, so we're going to plug into here. I've got negative B over 2 times A. Go ahead and figure out what that the axis of symmetry is going to be for me, please.
5 over 2.
5 over 2.
Yes, sir.
Negative cancel out.
So I'm going to get 5 over 2. What does that mean?
You go 5. You go up 5 to the right 2.
It's 2.5.
What's 2.5?
The axis of symmetry is at
2.5.
X
Yeah.
equals
I was like,
2.5.
what?
Okay. 1, 2, 3. So right here?
No.
I said X equals 2.5.
Oh, I didn't hear you say that. Good job. Let me go back. So 1, 2, 3, 2.5. Here's my axis of symmetry. That means, what does that mean exactly?
That's where the 0, 0 is. That's where the vertex lies.
That's where the vertex has to be, right? Is it going to have the same x value? Yeah. So we just got to figure out where it is exactly, right? If it's up here somewhere. Okay. How do I get the other part then? If I already know that my x value is 5.5, how am I going to get the y piece to it? So I can get that vertex.
Plug it in.
Plug in to what?
The original equation.
What am I plugging into the original equation?
5 over 5.
Okay, so can I get rid of this for now? Okay, so let's plug it in. We've got x squared minus 5x plus 6. I'm going to go 5.5 in here, 5.5 in here.
2.5 times
What do I have at the beginning? What's 5 squared?
25.
What's 2 squared? 5 times 5
25.
over, have a good day, plus 6. Someone simplify this for me, please.
Negative 25 over
Where?
4.
Out of 5 over 2, how is that 2.5? Like for where our axis is.
Divide it. How many times is 2 going to 5? 2 times. So here, let's do that. 2 goes into 5. 2 times. We got 4. Remainder 1. 1/2.
Oh, you just didn't simplify.
Is negative.
Well,
is
we leave it as
negative
5 halves.
25 over 4 plus 6, right? then you gotta multiply that one by 2. So
Yeah, so what I want to do, what do I need to get here? A common
denominator.
denominator?
Yup.
Anastasia?
Negative 25 over 4.
So that's going to give me minus 50 over 4 plus,
6.
not 6, because I want a denominator of 4. There was a 1. This got 4 times bigger. What happens here?
24.
24 gets 4 times bigger as well. So now we can do it because now they have the common denominator. 25 and 24 is 49. 49 take away 50 is going to give me a negative 1/4. So let's go up here. Let's go up here. We've got 5 over 2 comma negative 1/4. Okay? So this thing's actually going to be down here a little bit, isn't it? Okay? So we have our sketch. We know that this vertex is at 5/2, comma negative 1/4. Where's the y-intercept at? Can I get rid of this? Hold on. Can I get rid of this, or anybody still writing this down? Daisha, you good? Okay. Where's my y-intercept at?
Negative 1.
Remember, it's at 0. It's at 0, comma c. What's the value of c? 6. So 0. Whoa, that's way up here. Okay, so it's going to kind of do this bit. Do you see that I have I crossed the x-axis in 2 places? That's what we need to get next. Okay, because we can find a vertex now. We can find the y-intercept. I need those 2 x-intercepts. So here we go. You guys ready? So this is gone. Gone, 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 gone. Okay. Do me a favor real quick. Do me a favor real quick. Go ahead and factor this. Factor this.
Is that?
Yeah, factor it.
Like the X. That's fine.
Let's factor that real quick before we go after our x-intercepts. I want you to factor it real quick.
Then it'd be x minus 6.
Okay, this is what we were doing yesterday, right?
X plus 1. X minus 6. X plus 1.
Romo, you got this one? We're trying to factor that. Because we already have a y-intercept, we have a vertex. We're after these x-intercepts. Just as you already factored this? When the bell rings.
We factored that.
You factor this. When you're ding, 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 you can go. Who has this?
I think I
Not
did.
yet.
Not yet? I'll give you guys another few seconds here.
X minus 6 and x plus 1.
Wait, Mr. Munoz, can you come help me?
No, x minus 6 and x plus 1.
Oh, I thought I had a marker. Thank you for asking your questions. Okay, so let me go back to, yes, absolutely. Yeah, go ahead. All right. Thank you. Thank you. Thank you. Looks like some people are struggling with this factoring. We could do the XFAC method, but I'm going to do just the quick way. Just because this doesn't have that A value. I know that the 2 numbers that I pick have to multiply to this number, and they're going to add up to this one. Okay? That means I'm going to get a 6 and a 1. This is going to be a, oh, that can't be a 6 and a 1. It's going to be a 2 and a 3. 2 and a 3, and they're both going to be negative. Let me tell you why. 2 numbers that multiply to a positive means you're either going to get 2 positives or 2 negatives, correct?
But
The question is, which one's it going to be? Well, look at the middle, and it'll tell you what's going to be. Okay? To get positive, I need 2 negatives. And there's my breakdown. So, we were using the zero product property, correct? That's how we're going to find our 2 x-intercepts. Remember you said, why are we going to do this? Because we're trying to find, let me use green. I'm trying to figure out where it crosses, here and there. I've broken it up. Here's what you're going to do. I'm going to set it equal to 0. That should make sense. That should make sense. Let me tell you why. How do I find a y-intercept? How do I find a y-intercept? I make x 0, don't I? So our y-intercept is at 0, comma c. to find x-intercepts, guess what we do to y? We make it 0. So that's what we're doing when we do this. We're taking our equation and we're making y equal to 0. That gives me x-intercepts. So here's the question. This is a number. This is another number. It's one number times another number, and I got 0. What does that tell me about the stuff under the green blob?
0.
That it was 0, right? So here's my question. If this number was a 0, what would x be? 2. If this was a 0, then what was x?
3.
And guess what? Those are my intercepts. Those are my 2 x-intercepts. Bop, bop, bop.
Okay, hold on.
It's not easy being cheesy. Questions on what we've done?
So the,
Go ahead.
so the points for x would be on 2 and 3.
Oh, I can't hear you. Zoe? I think I'm going to have you closer over here to me. I got to move somebody. I'm going to go big on you guys. 4 corners. Pop, pop, pop.
You just got
But there's only 3 of you, though.
I'll talk about anybody.
That 3 corners.
Whoa. Okay. You're correct, but I want you talking about this. And you weren't talking about this.
How you know?
Because I can hear you.
What did I say? What did you say?
I'm just going to hear Courtney, so
Somebody draws.
I'm going to have to change my social objective over here to be the freshman objective, where we give the speaker the attention. I think we should already know that, right? Courtney, what was your question? One more time, that's not loud.
So, so the x is going to be on like the x-axis, so how does that affect, does it affect how much it stretches, like how wide?
No. All that's telling me, and you know what, if I drew this pretty, let me try to draw this pretty. Let me put it on another slide. Okay, so here's what I know. Check it out. We know that the vertex was at 2.5, 1/4. It's like right about there, right? And then we knew that the y-intercept was at 0, 6. 1, 2, 3, 4, 5, 6. That means that over here, what is that? Half. Is it right here? But now I need the y. This thing has to cross, doesn't it? And it's kind of easy to see from here that it does cross at 2 and at 3, but sometimes it's not that easy. And all we're really trying to figure out is where it crossed. That's all we're after. What are those called? If this is called the y-intercept, then what are these called? The x-intercepts. The x-intercepts. But they're also called them zeros. Okay? And that's all we're saying. Whenever we say x-intercept or if they say 0, they mean the same thing. This is nickname. You can be okay? Yeah, because now you look kind of scared.
Nah.
Okay.
I know.
Are you feeling the food coming back or something?
Nah,
What is it?
those medicines you gave me was my head.
Oh, okay.
I'm tired.
All right, cool. So we have the 2 intercepts. Show me thumbs up, thumbs down. We're good? The hard part was factoring it, wasn't it? Once it's factored, I can do this. That's not bad.
Nah, I feel like that's gonna get confusing.
No, it's not, because you can already factor here. Let's go right here real quick. I'm going to skip all that fancy stuff, okay? We're going to go straight to what we're doing today. Let's find x-intercepts. Let's find x-intercepts. That means that I've got 2x squared plus 7x minus 15, and all of that equals how much?
0.
You guys okay with me moving that 15 over?
Yeah.
Okay. The hard part here is going to be factoring it. Ladies, Zoe, why me? Why me? Here we go. Let's Xbox this guy. So this is going to be negative 30x squared, right? And what goes here? 7x. What two numbers multiply to 30 and will give me 7?
5.
Oh, 3 and 10.
Yeah.
3 and 10. I would have to have a positive 10x and a negative 3x, right?
Yeah.
Cool beans, that works. Let's go over to the box. So, first one, what goes in the first box? The first number, 2x squared. What goes in the last box? The negative 15. And then it doesn't really matter where I put my other two. I'm going to go 10x here. Is that cool with y'all? Negative 3x. So, here we go. Factoring up, what do we take out? 2x. Going up here, what do we take out? Negative 3. Let's go this way now. What are we taking out? X. Going this way, what are we taking out? 5. Okay. So that means that I've got x plus 5. I'm just going to double check if you guys don't mind. That should give me negative 15. That's 2x squared. That's good. So I've got 10 minus 3. We're good. We're good. So let me leave that up for a second, because all we did was factor. All we did was factor this problem. The next part is what we're doing today. This is what we did yesterday, the factoring piece, right?
The part with the graph, is that what we're doing today, like for homework and stuff?
The zeros, the x-intercepts.
That's what they're gonna ask for in Math Excel. They're
This
gonna
is what
ask
we're
for
doing today.
zeros.
We're looking for x-intercepts. What are we doing today? Looking for?
X-intercepts.
Yeah, we're finding zeros, x-intercepts. We're finding zeros, x-intercepts. Can I get rid of this?
No.
No, of course not.
Not yet. Not yet.
Romo? You okay? Kind of had a face there. Are you one of those people that when you get real sore, you just kind of poke at it the whole time? Though?
Oh, that be doing that.
I used to do that when I was back when I had muscles.
Because I get used to it after a while. I'm like, I don't hurt no more.
No, it still hurts. You just want to keep doing it.
Yeah.
It makes me feel alive. All right.
Is it mirrors on that screen?
Ah, dude, it's too hot. I'm gonna turn it this way. All right, we're good. All that we have done is to factor it. Watch what I'm going to do here now. I'm going to take my factored form. What is it equal to? 0, right? That means that 2x minus 3 is 0. And that x plus 5 is also equal to 0. You guys remember how to solve these guys? I'm going to go plus 3, that's 0. 2x is equal to 3. Divide by 2. What is this? That's one of my x-intercepts. Let's go over here. Minus 5 minus 5. Guess what this is? That's my other intercept. So when I'm going to graph it, that's my 2 x-intercepts for that parabola. That's it.
That's all.
There's not. There's
I just
Okay,
had this.
so-
I just had this in
The
my
first
brain.
problem is it seems so much more complicated.
Medicine kills.
No, go ahead.
Medicine kills. Nothing medicine. My brain doesn't correspond no more.
I'm gonna take what I just said back, Munoz. It is a lot of work, but it's a lot of work because now we're putting everything together, aren't we?
Yeah, but can you, so you can't factor it before putting into the zero, like that equation? Or do you have to put it into that equation and then factor it?
Can we just
and
find
then-
the vertex first?
No, hold on.
Is that possible?
You could factor it right from here, but how are you gonna factor with 15 on the other side? All I did was move it over, and then I factored it,
And then you just put.
and then I said each one equal to 0, and that was it.
Can we just
Then
like?
how come the other one looked like a lot more weird?
Because we did more work. We found the vertex.
Can we find the?
We found the
Are we allowed to
y-intercept.
find the vertex first or not?
Because I was showing you where this ties into what we were doing.
So right now we're just doing this.
We did this part. This part is
Well,
for today.
hold on.
Yesterday was last.
You
part.
cannot. Why me?
This is like part B. You know what I mean?
That's not a cell phone.
The other thing.
That's not a cell phone. Can't be a cell phone. There's no cell phones allowed during class.
Where? Right.
Right there on your lap.
Oh, yeah, that's my phone, but I'm in on it.
Put it away, please. What phone? That was great. Don't do that. Don't say we're only doing this, because you have to understand. Here's where people get lost: is they think, oh, this is all I have to worry about. but you don't see the big picture of it.
So,
Okay? You don't want to lose that big picture.
yeah, but why did you do the rest, but right here you didn't? Because you were gonna.
Because I saw people who were going, wow, that's a lot of work. But what we're doing today really isn't a lot.
Like, I get it
It's a
when
piece
the
of it.
steps, pero cuando lo pones todo junto, it's like.
Well, let me tell you something.
It's like when you put it all together.
Okay, so, thank you. Thank you. Thank you. Yeah, exactly. I don't have that social objective right now up, but one of the objectives that we will have socially is to be able to persevere through a problem and get all the components. Right now, Algebra 2, hopefully, I think everyone here is going to go to college. And you're going to have to get to this thing called, like if you want to be done with math, to get your degree, there's two courses. There's two versions of college algebra. One version is for those people that are going to need more math, and there's going to be one for those people that I don't need any more. Okay?
I'm done at high school.
And when you get to that college algebra level, some of these problems are not going to be like what I have here, like a couple steps. It's going to be, you have to persevere, and you have to get through it, and you will have those multiple steps. Right now, all I'm trying to do is chunk it for you.
No, I get that, pero I'm not complaining that it's a lot. I'm just saying like.
She's
Let's
lost.
see. No, I'm
It's
not
a lot
lost
to
though, 'cause-
comprehend.
No, not even that. It's just that it's. I'm asking if you did the other steps like for the vertex and all that to plot it like onto the graph.
Right.
Or, okay, so that's what you used it for.
This is just a part of it.
Yeah, see, that's what I was trying to ask because I
Okay,
didn't understand.
then I was
If
just
that's what you
completely
needed to graphic. I
Yeah.
don't know.
So when we did the other one, we had a lot more things, right? Remember, we found the vertex, we found the y-intercept,
I know that.
and then we found the x-intercepts. For this case, all we did was find the x-intercepts.
So we would only need like the axis and separate.
Hold on. Guys, a little professional courtesy, someone's talking, go ahead.
I was asking like, so the thing that we just did to find the vertex first, but we only need to find that whenever they only ask us that, right?
Yes, you would find it when they ask you for it, but you're really going to want to find some time to do that. I'm going to tell you right now, when you take your test, you'll probably have one problem where they give you that and they're going to say, hey, and they're going to walk you through all of these things we just did. First thing they're going to say is, hey, where's the vertex at? You got to find the vertex. Or they might even say, where's the axis symmetry? Plug in the axis symmetry. Hey, then where's the vertex? Here's the vertex. Well, then what's the y-intercept? Here's the y-intercept. Then what are the x-intercepts? And you got to find the x-intercepts. So you're going to have a whole flow of problems there,
That's
okay?
a lot of work.
It is a lot of work.
I would take calculator.
All right.
Thank you, Jeremy.
We'll pick this up tomorrow.